Greetings, my name is Elizabeth Wade. I teach basic calculus in the mathematics department at Pellissippi State Technical Community College. This is topic 5 on integration and segment 5.8 on rate functions. In real-world application problems, we often need to find the net change in a rate function over a period of time. The net change in a function over an interval, a,b, is given by the expression, the definite integration, f of b minus f of a, equal to the integral from a to b of f of x dx, provided that the function is continuous on the interval and where cap f of x is an antiderivative of the function. Let's look at an example. A company has determined that the marginal cost function, remember a marginal is a derivative, so this is our rate function, for producing an item is given by this expression, where the derivative c prime of x, the marginal cost, is measured in dollars and x is the number of units produced. Our job is to find the total cost, not the marginal cost, but we want to go back to the cost, the total cost of producing the 201st through the 400th unit. Well, we can set this up as a definite integration problem. To get this, we can integrate from 200. Notice that I use 200, not 201. We integrate from 200 to 400, the function with respect to x. Let's work this problem on our calculator. The first thing I need to do is to type in the function. So we have 0.00003 x squared minus 0.003 x plus 2. Then I'm going to set my window, and I'm going to set my window from 0 to 500 with a scale of 500, and then from 0 to 2 with a scale of 2. And let's graph this. We were integrating from 200 to 400. I'm going to go to second calculate, select number 7, put in for my lower limit 200, put in the upper limit 400, and notice that the calculator shades this area under the curve from 200 to 400 and gives me an answer of 276 as the area of this region. Notice that the area of the shaded region on the closed interval from 200 to 400 represents the net change in the cost of changing production from 200 to 400 units. Now let's go back to our notes and look at another problem. The marginal cost to produce x units of a product is given by 4x plus 10, and the marginal revenue is given by minus 0.8x plus 490. Compute the total profit from increasing production from 0 units to the production level where profit is maximized. First, notice profit is maximized when marginal revenue and marginal cost is equal, which would be this point of intersection. If you graph these functions on your calculator and determine the point of intersection, notice that this occurs at x equal 100. This is marginal revenue, and here I've graphed the marginal cost. So marginal revenue is above the marginal cost. And this region bounded by these two functions would be the profit, the total profit, in increasing production from 0 to 100 units. Well, recall that profit is revenue minus cost. So to find the total profit, I'm going on this interval from 0 to 100, I'm going to integrate from 0 to 100 the derivative of the profit function, which means we're going to integrate from 0 to 100 r prime of x minus c prime of x. So in this case, we have the integral from 0 to 100 minus 0.8x plus 490 minus 4x plus 10 dx. If you want to simplify this first, before you integrate or before you use your calculator, you would have minus 4.8x plus 480 dx. By hand, if I integrate, I would get minus 2.4x squared plus 480x evaluated from 0 to 100. And if you complete this integration, you end up with 24,000. Again, you can always switch to your calculator and use Math 9. Type in the original expression or this and evaluate it from 0 to 100 to yield $24,000. And the $24,000 is the total profit in increasing production from 0 to 100 units. Well, that's it for this segment. Now you need to practice this concept by working similar problems. Good luck.